Hello and welcome to a brand new episode of the universe's greatest podcast, because it's the only show that tries to search through the secrets of the whole thing. It's the Fun Kids Science Midweekly. My name is Dan. This is your quick, bite-sized science special every Wednesday. You've been sending in your questions. Thank you so much for that. This week, they're all about the Earth and the solar system. You can hear my theory on how our planet was made, what's in the centre of the whole thing, and how long it would take Neptune to orbit the Sun.
Hi Dan, my question is, how did life on Earth begin? Thank you.
Thank you, Andrew. How did life begin on Earth? Well, if I knew that, I would be much more powerful than I am right now. Well, if anyone knew that, we've got a good idea, though. Scientists can never properly find out because this happened 4.5 billion years ago. That's when it all kicked off. So they've got some ideas. Some experts think that deep down in the ocean, molecules, chemicals gradually changed and evolved into more complex molecules, which developed and developed over millions of years until there were animals, which then evolved, and the better animals that were more equipped to deal with life and thrived then survived, and that's led to where we are today. That's one idea. There have also been some experiments which have tried to copy what the early Earth would have been like. Back in 1953, some scientists, Stanley Miller and Harold Urey, created an environment with water, a gas called methane, ammonia, and hydrogen that was similar to how they think the Earth would have been like billions of years ago. And then what they did is fascinating. They put electricity through the water, trying to mimic and create what a lightning bolt would have been like. And then they saw tiny amino acids were made because the charge from the electricity kind of stimulated all the elements that they'd created, right? And those amino acids are the building blocks of protein, which are the building blocks of life, which suggest that maybe life can grow from simple molecules that existed all that time ago, that maybe it was a bolt of lightning which kicked off life as we know it. So that's an idea. Some scientists have also thought through that life might have started around hydrothermal vents on the ocean floor. So deep down, there are almost gaps in the crust of the Earth which spew out really, really hot air from deep down underneath the planet, and that hot air would have released mineral-rich water with chemicals into the ocean, which is where life came from, Andrew. So thanks for that question. We will never properly know, I don't think, for years and years and years and years. But those are a few ideas that scientists are working with. Let's get on another question then, sent through as a voice note to funkidslive.com from Finley.
What is it like in the centre of the Earth?
Well, I've never been there myself. I hear tickets are quite expensive. But in the centre of the Earth, you find the core. It's about 1,800 miles beneath where you are stood right now. That means it's very hard to properly study. But scientists have done tests with computer modelling. They've analysed meteorites that we think is similar to how the Earth is. And by also reading data from earthquakes and tremors beneath the Earth's surface, they've got an idea of what's deep and down there. And they say the core is made up of two parts. You've got the outer core and the inner core. Now, the outer core is liquid, mainly molten iron, and it's extremely hot. There's a lot of pressure with the Earth pushing down, and because of the heat, it means that it's always a liquid bubbling around. In the inner core, inside that, you've got more iron and nickel, metals, minerals, but because there's so much pressure, so much of the Earth sitting on it, it squeezes it down into a solid. So the outer is a liquid, the inner is a solid, and it's hot down there. I mean, it's more than boiling. The temperatures can get up to 9,000 degrees Celsius. And if you're in the UK like I am right now, the temperature's about 3 degrees Celsius. So it is roaring hot down there, Finley. Thank you so much for the question. Here is one from Arlo.
How long does it take for Neptune to go round the Sun?
Neptune is the 8th and the farthest known planet from the Sun in our solar system, so it's a perfect choice. It takes 164.79 Earth years for it to go round the Sun. So their year is 164 years long. But here's what's amazing. Neptune has very quick days. A day here on Earth is when the planet makes one full rotation on its axis, right? And on Neptune, that only takes about 16 hours and 6 minutes. So they have very quick days. But because it's spinning around so swiftly, it's got a very distinctive atmosphere with high-speed winds charging around it and thick storms too. Arlo, thank you so much for the question. Let's get one more on this very special bonus episode of the Fun Kids Science Weekly, sent through as a message to me at funkidslive.com. Kyle's there, who wants to know what's in our blood. I hope you're not a vampire, because then I'll be giving you tips. Kyle, blood is made of cells and plasma. Plasma is a yellow fluid that's in there. It's thick with nutrients, proteins and stuff that keeps you alive. In the blood, you've got different cells which have different jobs. The red blood cells carry oxygen around and they move to different parts of the body and they power your organs and your muscles. You've also got white blood cells in there. That's part of your immune system and they fight bacteria. So if any nasties like viruses want to get in, it's your white blood cells that get to work. You've also got stuff called platelets in there. They are tiny cells that are oval shaped and they get to work if you've been cut or something, if you've fallen over and you start bleeding. They get to work, they help clog up and fix wherever the blood is leaking from. So that's what's happening with platelets. So that's what's in your blood, Kyle. Thank you so much for sending over your questions. Thank you for your question. If you have anything that you want answered, let me know. The best way is to send it to the website, funkidslive.com. Find the Fun Kids Science Weekly podcast right there. There's a big red button. Click it, say hi, it'll record, tell me your name, let me know what you want to know. And now, I want to know everything from Marina Ventura. She's back with her trusty sidekick map app. And we're exploring how electricity is moved from place to place.
Marina Ventura, Energy Explorer.
Hi guys, Marina Ventura here. I am on a mission to explore the what, how and why behind the electricity we use and find out some cool stuff about how things are changing. Want to come too? Excellent! Have you ever thought about how electricity actually gets to our homes, schools and places of work? Well, there's some seriously cool technology that's used. Isn't that right, Map App?
That's correct. Electricity is generated in power stations that burn carbon fuels or use nuclear fuels to create steam that drives turbines. Basically a rotating shaft with blades. Then, powerful electromagnets create the electricity. The energy has changed from chemical energy to kinetic and mechanical energy in the turbine to create electrical energy.
And what about renewables, such as wind power?
The movement of the sails is kinetic energy, so essentially it's fast-tracking the energy to the point where it's ready to be turned into electricity with electromagnetism. Once the electricity has been created, it needs to be moved to where it is needed, and this step is known as transmission.
Ah, this is like the motorway network that connects our cities together and helps us get from A to B quickly and safely.
That's right. There's a national grid of pylons connecting over 7,000 kilometres of overhead lines and also 600 kilometres of underground cables to take the electricity to where it needs to go. But the electricity isn't quite ready to set off.
I'm guessing it's not because it needs to pop to the loo or grab a packed lunch for the journey.
Well, really, no, the electricity just needs to be increased in voltage. Most electricity is generated at 22,000 volts. It's increased to as much as 400,000 volts to help it travel more efficiently over long distances.
How's that done?
Through things called transformers. You might have seen strange-looking electrical yards with lots of machinery around your town or on the edges of motorways. These are substations. They are junction points where transformers change the voltage and direction of the electricity. They increase the voltage to move electricity around the country and decrease it again when it's close to its destination, so that it's safe to be used. After all, 400,000 volts is over 1,500 times more power than we use in our homes. At the substations, electricity is reduced in power, with different customers taking supply at the right voltage for them, Large industrial companies might take it direct from substations at 33,000 volts, whilst smaller industrial customers, towns and villages will take it at 11,000 volts. It's finally reduced all the way down to 240 volts for use in our homes, schools and shops.
Now, when people get their electricity bills, it can be from a variety of different companies. So what's that all about?
Well, generating, transmitting and distributing electricity are just 3 steps in the process, each done by very different companies. Then there are a large number of supply companies who actually sell the electricity to homeowners, shops and offices, and raise the monthly bills.
The important thing is that supply is always there when needed.
That's right. Energy generators, transmitters, distributors and suppliers are always working together to find smarter ways to make sure there's enough to go around, from sharing electricity with other countries to encouraging people to use more energy efficient equipment and to use electricity at different times of the day. After all, you don't need to charge a car or wash your clothes during the day. You can do it at night when there's less overall demand.
What happens when something goes wrong?
A transmission network control center monitors the grid 24/7 to make sure electricity is moved around the network safely and gets to where it's needed. And if an alarm does ring, it can respond at any time of the day to resolve any issues and make sure supply is restored.
And make sure that our gadgets and appliances work where and when we want them. Brilliant!
Marina Ventura, Energy Explorer. Find out more about National Grid and how Grid for Good is helping climate change at funkidslive.com/Marina.
If you want to find out more about Marina, head to funkidslive.com and search for Marina Ventura. Now, the Fun Kids Science Weekly full-length episode is back this Saturday. This week, we'll dig into why archaeology matters with Alfredo Cortel Nicolau guiding us through the secrets of the past.
Imagine that you are in an archaeological site and you are there digging, and then at some point you find an arrowhead, and that arrowhead is 10,000 years old. And then you could be the first person seeing that arrowhead in 10,000 years. And from that, you could start learning, you could start questioning and thinking, how was people doing things in the past?
And we're uncovering if Earth will ever leave the Milky Way galaxy. Where would we go? Where would it end up? How could that happen? We'll find out in a brand new Fun Kids Science Weekly in a few days' time. And remember, this podcast is going on tour. Find out where you can see Fun Kids Science Weekly live right now for an hour of experiments, fantastic guests, dangerous beasts, and things from outer space. Get to funkidslive.com/tour. Can't wait to see you there.